Hi, Scooby.
Scooby, Scooby-Doo, looking for you. Scooby, Scooby-Doo, where are you? All the stars are here, waiting for you. Couldn't have a show without you.
Hello, let's talk about using all those factoring skills you just learned to solve equations. And we have a property here that says if you have two factors multiplied together to give you 0, in other words, a times b equals 0. Now a might look like a factor like x minus 2, and b another factor like x plus 5 equals 0. Then either a equals 0 or b equals 0 or both. Now that makes sense, right? If you multiply two things together, so something times something else to equal 0, surely one of those things has to be 0. The only way to multiply two values to get 0 is if one of them is 0. And that's what this product is saying, and that's pretty powerful when you go to solve equations. If you have 0 on one side of your equation, and you have two things multiplied together called factors to give you 0, then what you know from above is either x plus 4 equals 0 or x minus 3 equals 0. And you solve each of these equations separately. So I subtract 4 from both sides of the first equation to get x is equal to negative 4. That's one of the solutions to the equation. And then we add 3 to both sides of the second equation and get x equals 3 is the other solution. So if x is either negative 4 or 3, then that's going to make this equation true. Alright, so let's try it again. So when you look at this next equation, it says y minus 1 times y plus 7 equals 0. Now notice this is two things you're looking for. It needs to be in factored form, and that is definitely factored, and it has to be equal to 0. If there's not a 0 over here, there is no property that you can use. You will have to do something to the equation to get a 0 on one side. So this is required, and it must be factored on this side. So once it is, I can say y minus 1 equals 0, or y plus 7 is equal to 0. When I add 1 to both sides of this equation, I get y is equal to 1. If I subtract 7 on both sides of the second equation, I get y is equal to negative 7. Again, notice there's two solutions to this equation, y equals 1 or y equals negative 7. For our next example, we want to solve 3x plus 1 times 2x plus 5 equals 0. So remember those two things that I told you are very important. You have to have a 0 on one of the sides, and you have to be factored on the other side, and that is the case here. So 3x plus 1 parentheses 2x plus 5 means we are factored, which means I can separately set these two factors equal to 0. Again, I can't impress this enough. If there's not a 0 on the other side, you cannot do what we're doing right here. It must be 0. So I subtract 1 from both sides of this first equation. I have 3x is equal to negative 1. Then I divide by 3, and I get x is negative 1/3. So this is just solving a two-step linear equation. I'm going to subtract 5 from both sides of my second equation. That gives me 2x is equal to negative 5. And then I divide both sides by 2, and I get x is equal to negative 5 halves. So two answers. X is negative 1/3, and x is negative 5 halves. For example D, let's look for it again. It's equal to 0, check, that's what I need, and we're factored. Now I know this factor up front of just x looks strange, but it's a factor just like x plus 3 is a factor. So I set x is equal to 0, because that's one of my factors, and I set x plus 4 equal to 0, that's my other factor. Now x equal to 0 is actually already solved. The x is isolated on one side, you have your answer. Here I need to subtract 4 from both sides of my equation. Remember, you keep your equals lined up. These cancel. I have x and then equals negative 4. So my two solutions are x equals 0 or x equals -4. Either of those will make this equation a true statement, just like the fractions -1/3 and -5/2 will make this equation a true statement. For example, E, I have x minus 3 squared equals 0. Now that looks different, but remember what x minus 3 squared actually means. It means x minus 3 times x minus 3 equals 0, which is factored. So I can set x minus 3 equal to 0 or x minus 3 equal to 0. Now I know that seems silly because you get the same answer of x equals 3 both times. Now it would be okay to just type in your answer if you're doing this online homework as x equals 3. But really the solution is x equals 3 for both factors. But this is the only thing you would have to type in as your answer. Now we've run into a new type of problem here, for example F. And the issue is we do have a 0 on one side. That's what we need. But this is not factored. So don't try to set like x squared equal to 0, 3x equal to 0, -10 equals 0. It does not work that way. You must factor this first. And all those factoring skills we learned earlier now come into play. So remember, this is a trinomial. And to factor a trinomial with a leading coefficient of 1, we find numbers that multiply to be -10 and add to be -3. And when you think about those factors, first of all, one's got to be positive and one's negative. And the bigger one is negative, so that's a -5 and a +2 that would do that. So that means when you factor this into a set of a binomial times a binomial equals 0, keep the equals 0 lined up, it's going to be x minus 5 times x plus 2 equals 0. Now you separately set each of these factors equal to 0, just like what we learned earlier. I add 5 to both sides of the left equation, so I get x is equal to 5. And I subtract 2 from both sides of the right-hand equation to get x equals -2. So the two solutions that would make this equation true, and you could certainly check it by taking those and plugging them back in, are 5 and -2. Let's check 5. Real quick, let's just do a quick check. So I have 5 squared minus 3 times 5 minus 10. Does that really equal to 0? And I got 25 minus 15 is 10. 10 minus 10 is 0. And that checks out. You could also check the -2. And every one of these problems you can check and should check. All right, for our next problem, G, y squared minus 8y minus 9 equals 0. Again, a couple of things you're looking for. You need to be factored on one side of the equation, and you must equal 0 on the other. And is that the case? Well, one of them is true. I've got it equal to 0, but I am not factored here. So this I must factor first. Then you look at what type of problem it is. So this goes back to our previous factoring skills. I have a trinomial with a leading coefficient of 1. So in this case, I can try to find numbers that multiply to be -9 and add to be the middle coefficient, which is -8. The numbers that do that are -9 and a +1. Check it by adding them. You get -8. Multiply them, you get -9. So that means this factors into y minus 9 times y plus 1 equals 0. I separately set these two factors equal to 0. Remember, if there's not a 0 over there, you have to do that first. I add 9 to both sides. I get y is equal to 9 as one of my solutions. I subtract 1 from both sides, and I get y equals -1 as my second solution. Again, you could check it by plugging your 9 and your -1 in. So I would have 9 squared minus 8 times 9 minus 9. Does that really equal 0? And I'd also check -1 squared minus 8 times -1 minus 9. Is that really equal to 0? Well, let's check. 9 squared is 81 minus 72 minus 9. 81 minus 72 is 9 minus 9 equals 0. Checks. Over here, negative 1 squared is 1. Negative 8 times negative 1 is plus 8. Minus 9 equals 0. 1 plus 8 is 9. 9 subtract 9 equals 0. That checks as well. It doesn't take long to check. I may not check all these just due to space on my PowerPoint or time, but you always should check yours, especially when you're taking a test. All right, let's look at our next problem. Our next problem is different. Remember the two things we're looking for? We're looking for factored on one side and equal to 0 on the other. And we have neither of those here. So this is not equal to 0. We must handle that first. So if I want a 0 on the right-hand side, I need to subtract 9a. Remember, I keep my equals lined up. So on the left, now I have a squared. Now I could put plus 14 minus 9a, but that's not in the order we typically have our problems. Is descending order helps. So I put the minus 9a in the middle, so it looks like a regular problem that we factor. On the right, notice 9a minus 9a is 0. Now this is what we need, is a 0 on one side. The next thing we need is to factor our polynomial. Now in this case, we have a trinomial with a leading coefficient of 1, which means if I use the trick of finding numbers that multiply to be 14 and add to be negative 9, I would do it. Now remember, every polynomial or trinomial does not factor. If you can't find those two numbers, that might mean you're dealing with a prime. And there are other ways to solve those that we're going to learn later in this course. But right now, all of these should factor. Multiplies to be 14, adds to be negative 9. How about a negative 7 and a negative 2? Check it for me. If I add those together, I get negative 9. If I multiply them together, I get 14. So that's what we need. That means I factor this into a minus 7 times a minus 2 equals 0. Now it's time to separately set each one of these factors equal to 0. I add 7 to both sides of this linear equation to get x equals 7. I add 2 to both sides of the second linear equation to get a equals 2. And now I have two solutions to this quadratic equation. And that's a new term for us, but any equation that has a square as your highest power, in other words, that's the degree of your polynomial, is going to have two solutions like we're finding now. All right, problem I. So we're supposed to solve this quadratic equation of 3c squared equals to 10c minus 8. Now remind yourself the two things we're looking for. We must have a 0 on one side of our equation, and we must be factored on the other side. And if you look at this problem, neither of those situations is going on. So the first thing you must do is get equals 0. Do not factor this until you have 0 on one side. Now, you could subtract the 3c squared on both sides, but I don't like my square term negative. It is much easier to factor a trinomial or any other polynomial if your leading coefficient's positive. So I'm going to leave the 3c squared on the left, and I'm going to subtract 10c and add 8 to each side of this equation. Okay? Now, again, the reason I'm minusing 10c because this is a plus 10c and I want that to cancel. The reason I'm adding 8 because this is a minus 8 and I want that to cancel. That gives me a 0 on the right. Equals comes straight down where my vertical line is. And on the left, I'm going to write this in descending order. The 3c squared is still first. Minus 10c plus 8 equals 0. So now I'm at my factor stage. I must factor this polynomial. Well, it's got an extra issue we haven't dealt with in this video, but this is a trinomial that does not have a leading coefficient of 1. And you can either do this by trial and error, or you can use the AC method like we learned. If this method is unfamiliar, please go back a few videos and watch the video about factoring trinomials with a leading coefficient not equal to 1. What you do is multiply 3 times 8 to get 24. So I'm trying to find multiples of 24 that add to be the middle coefficient of negative 10. And that's going to be a negative 6 and a negative 4. Check it. That does add to be negative 10. It does multiply to be 24. Now, the next step is I do a factor by grouping step. I rewrite the negative 10c is negative 6c minus 4c. So I'm using those two values that I found. The plus 8 is still part of my problem, and so is the equal to 0. Now I factor by grouping the first two and the last two together. Greatest common factor out of the first two is 3c. That leaves a c minus 2 in parentheses. In the second set of parentheses, the greatest common factor is negative 4. That leaves me with c minus 2. Remember, that step is required that these match, because the next thing I do is pull that out front and write c minus 2 times 3c minus 4 equals to 0. Now I am factored on the left, I am equal to 0 on the right. So finally, it's time to set each factor separately equal to 0. I add 2 to both sides of the first one, and I get c equals 2 as one of my solutions. I add 4 to the second equation. I'm going to add 3c equals 4, but I still must divide by 3 to get c equals 4/3 as my second solution. Again, I encourage you to check. I'm going to move on. And now we have 6a squared plus 9a equals to 3a. Again, two things. We must be factored on one side and equal to 0 on the other. I am looking that my square term is positive on the left already. So what I prefer to do is subtract 3a from both sides of this equation. Okay? Now this 3a and this 3a cancel to give me that 0 that is required on one side. On the other side, I have 6a squared just comes down, and 9a minus 3a. Now those are like terms. Notice the difference over here. We didn't have any like terms on the left. But 9a minus 3a is plus 6a. Now I'm at the factoring step. And remember, the first step of factoring always is a greatest common factor if your problem has one. This is the first problem in this video that's actually had a greatest common factor when we've gone to factoring, but we've got one. They both have a 6 in common, and they also have an a in common. Let's pull that out. 6a comes out, and that still leaves an a plus 1. Now again, if you missed that, let me help you out a little bit. Whenever you pull out a greatest common factor, what you're really doing is dividing each of your terms by that greatest common factor. So this 6 and this 6 cancel, and this a squared and this a leaves that a. And then this 6 and this 6 cancel, and this a cancel. And remember, when you divide and everything cancel, you're left with a 1. So 6a divided by 6a is 1. All right, so back to solving. I have my factors. So 6a is my first factor. I set it equal to 0. A plus 1 is my second factor. I set that equal to 0. To solve for this a, to remove the 6 that's being multiplied, I divide. So that gives me a equals, now a lot of people make a mistake. Y'all, 0 divided by 6 is 0. Okay? It's a 0. And then here I subtract 1 from both sides, and I get a is equal to negative 1. Again, you could check these. I've got a little bit of space. Let's check. So I plug in 0 in my original problem. So 6 times 0 squared plus 9 times 0, is that equal to 3 times 0? Well, sure it is. This is 0, this is 0, this is 0. So 0 equals 0. That checks. If I check negative 1, I'm going to do this in a different color. I've got 6 times negative 1 squared plus 9 times negative 1. Is that equal to 3 times negative 1? Well, negative 1 squared is 1. 6 times 1 is 6. 9 times negative 1 is negative 9. 3 times negative 1 on the other side of the equation is negative 3. Is 6 minus 9 equal to negative 3? Yes, it sure is. So it always helps to if nothing else, build your confidence to know you got it right if you check it. I encourage checking. All right, we've got a 25p squared equals 49. So remind me the two things I have to do: get it equal to 0 and factor the other side. Neither of those things is happening in this problem. So the first thing I'm going to do is get my equation equal to 0. The p squared, that's the highest exponent we're dealing with. Let's leave it positive. So I'm going to subtract 49 from each side of my equation. 49 minus 49 is 0. That's that 0 I needed. Over here, these are not like terms, so I'm going to write this as 25p squared minus 49. Now it's time to factor. Now, this is one of the most important reasons we learned the skill of factoring. There are other good reasons for it as well, but we need to be able to factor to solve equations, and to factor, you have to know all different factoring techniques. This is what we call a difference of squares. Okay, and what that means is 25p squared is a perfect square, 49 is a perfect square, and the absolutely required subtraction in the middle. Whenever you have a difference of squares, it factors into a binomial with a plus and a binomial with a minus. The square root of the first one, 25p squared, is 5p, goes in the first spot. The square root of the second term, which is 7, goes in the next spot. Now that is factored. The next step is to set each factor separately equal to 0 and solve. So I subtract 7 from both sides of that equation to get 5p equals negative 7. I divide by 5. To get p is negative 7/5. For my second factor, I add 7 to both sides. I get 5p equals 7, divide each by 5, and get p equals positive 7/5. And that's my two solutions. My next problem, L over here, has some big issues. Okay, first it looks like it's factored on the left, but we don't have 0 on the right. Now this would be one of those easy problems if I had a 0 over here. But the problem is I've got to get this equal to 0. So the first thing I have to do is subtract 4x from both sides of my equation. So that gives me 2x minus 1 times x plus 3, and then this minus 4x just hanging out at the end, right? Now over here, this is not factored because this is a big subtraction problem now. To get this to work out like I need, I'm going to have to distribute all of this. I'm going to have to FOIL this out, add like terms, and then go back and factor. So there's a lot of work involved here because this is not multiplied out. So I have 2x times 2x is 2x squared. 2x times 3 is plus 6x. Negative 1 times x is negative x. Negative 1 times 3 is minus 3. I still have my minus 4x equals 0. So now I have like terms to combine together. I have 2x squared. Now look, 6x minus x minus 4x. Those are all like terms. 6x minus x is 5x. 5x minus 4x is plus 1x. I'm just going to put plus x. This is minus 3. Does it have a like term? Equals 0. Now this looks like some of our problems a couple of pages ago, that we have a trinomial we need to factor with a leading coefficient of not 1. Now we could just do trial and error, folks, and figure it out, or we could do the factor by grouping step. Trial and error is where you just bring down your two sets of parentheses. What multiplies to give you 2x? Well, the only way to get 2x is if you have an x times a 1x. The only way to get a 3 is if you have a 3 and a 1. Now, it has to be negative, though. So the question is this plus 3 and minus 1? Check to see if that works. So 2x times x is 2x squared. 2x times negative 1 is minus 2x. Plus 3x is plus 1x. And 3 times 1 is negative 3. Now, I got lucky that I got that first, because there's 4 different options. Like, it could have been a minus 3 and a plus 1. Or the 3 could have been over here, and the 1 could have been over here, and then the sign switch as well. So I just picked the first out of 4 options. I got lucky. But now, the other method of doing factor by grouping and finding numbers that multiply to be negative 6 and add to be 1 and writing it out as 4 terms and then doing factor by grouping would still get you here. All right, now, once you are factored, you set, and you have 0 on the other side, both of those things required. You set each of these factors separately equal to 0. So I subtract 3, I get 2x is equal to negative 3, divide by 2, x is negative 3 halves. I add 1, x is equal to 1. That's my two solutions. Now, just in case you didn't feel comfortable with the last problem, I have two more that are similar, but probably a little extra work involved. Notice here, I definitely don't have a 0 on one side. I am not factored or anything, so I have to get this equal to 0. Notice my highest exponent, x to the third, is already a positive in front of that 8, so I'm going to leave this on the left, and I'm going to subtract negative 24x squared on both sides, and I'm going to add 18x on both sides. Okay? Remember, the equal stays where it is. The reason I did that is so those would cancel and those would cancel, and I get 0 on the left. All right, and then on the right, and then on the left I have 8x to the third minus 24x squared plus 8x. Now, here's another thing. This step that I'm writing to get it equal to 0, you don't have to write all that. If you want terms on the other side, notice you change the sign. Like 24x squared, I wanted it on the other side, now it's negative 24x squared. Negative 18x, I wanted it on the other side, now it's positive 18x. I almost lost a sign there, didn't I? Now I'm looking to factor. And when you factor, you should always look for a greatest common factor first, and 8x to the third minus 24x squared plus 18x does have a common factor of 2. I think is the biggest thing that I see there. Alright, so if a 2 and an x, so 2x comes out, that's going to leave me with 4x squared minus 12x plus 9 equals 0. Now here's the problem. This guy right here is one of those trinomials with a leading coefficient not 1. We could simply try to do trial and error, but a problem like this, the options, there's plenty of options, so I don't know if I want to do trial and error. So another thing we could do, oh hey, you know what I do notice though? That's a perfect square, and that's a perfect square, and you add to be a negative. It might be worth trying this, 2x, and is this square root of 4x squared is 2x, goes in the first spot. Square root of 9 is 3, but it adds to be a negative, so minus 3 minus 3. Let's just check it, see if that works. 2x times 2x is 4x squared. 2x times negative 3 is minus 6x. It's another minus 6x, which is minus 12x. Negative 3 times negative 3, look, it worked. Okay, so again, sometimes it's worth just playing around to see if the factors you have in your head work, and the square root of each of those just worked out. Okay, but now look, I've got 3 separate factors. I'm going to underline for you so you see there's a factor, there's a factor, and there's a factor. I'm required to set all 3 of those factors equal to 0. So I set 2x equal to 0, 2x minus 3 equal to 0, and 2x minus 3 equal to 0. Here I divide both sides by 2, and I get x is equal to 0. Here I add 3 to both sides. I get 2x is equal to 3 divided by 2, and I get x is equal to 3 halves. Add 3, I get 2x is equal to 3, and x is equal to 3 halves again. Okay, so notice this has 3 solutions. X equals 3 halves is the same solution. You would only have to type that in once, like if you were typing this answer, be x equals 0, comma 3 halves, or you might even not have to put the x equals part, but 0, comma 3 halves, but really it's 3 solutions with 3 halves as a solution twice. All right, let's keep going. Just a few more examples before we wrap up the video. All right, what are the things we're looking for? If you'll recall, we need a 0 on one side. So I'm going to add 22a to both sides of this equation. I get 12y squared plus 22a minus 20 equals 0. There's a greatest common factor here. A 2 divides into all of those, so that's 2 times 6y squared plus 11a minus 10 equals 0. This is inside here. It's not one of those perfect squares. I could play around with the factors of 6 and the factors of 10, or I could use that AC method, which I think is what I'm going to do. So I'm going to multiply 6 times negative 10 to get negative 60. Trying to find numbers that multiply to be negative 60 and add to be the middle term, which is 11. Things that multiply to be negative 60 and add to be 11. So 12 times 5 is 60. That'll work. 15 and 4 is 60. How about a plus 15 and a minus 4? That works, right? So I'm going to rewrite this. Also going to change to not as thick of a pen, so I'm going to rewrite. I've got 2 still in the front, okay? And this, I'm going to rewrite the 11a. So 6y squared plus 15a minus 4a minus 10 equals 0. So I replaced 11a with 15a minus 4a. That's the method. So I'm going to group these together and these together. So the 2 is still out front. I'm going to put some brackets here to keep this separated. 6y squared and 15. I'm sorry. I got y's and a's. That's a mess, y'all. We have to change this to a y. Why didn't I notice that before? If you got these different variables, that's not going to work. Okay. That's a typo on my part. I apologize. Alright, so 3y must factor out. Okay, it's going to leave us with 2y plus 5. Did you catch that? So what I did is I found the greatest common factor of 3y to these first two. I divided by 3y here, divided by 3y here. That gave me the 2y plus 5. Now I'm looking at this second set, this minus 4y minus 10. And they appear to have a negative 2 in common. So I'm going to divide by negative 2, divide by negative 2. And when I pull out that negative 2, that's going to leave me with 2y plus 5. Remember, that's required that those two sets of parentheses match. So I have 2 still out front. The one that matches, 2y plus 5. Times what's left out front, 3y minus 2 equals 0. Now what do? It's just to set each factor, and I have 3 factors, this one, and this one, separately equal to 0. And the fact is, 2 equal to 0 doesn't make any sense. There's no variable there, so that does not give you a solution. But 2y plus 5 equals 0. If I subtract the 5 and divide by 2, gives you y is negative 5 halves. Left some steps out there. I'm sure you can follow that. 3y minus 2 equals 0. I add the 2, divide by 3, and that gives me y equals 2/3. Make sure you follow that. I added 2 and then divide by 3. And those are my 2 solutions for that problem. Now let's see if we can't apply these skills to some word problems. So we've got the product of 2 consecutive integers is 756. Find the integers. Okay? Now, the product of 2 consecutive integers. So what does that mean, consecutive integers? It means they're right next to each other, right? So if I call the first one, let's just say x. There we go. The first one's x. And the next one would have to be x plus 1. That's what it means to be consecutive. They're right next to each other. So first number's 5. The next number would be 6, right? How do you get from 5 to 6? You just add 1 to it. So that's what it means to be consecutive integers. Now it says product. What does product mean? Well, product means you multiply these together. So it's this one times this one. And then it's equal to 756. So there's our problem. So anytime you see consecutive integers, that just means if the first one's x, the next one's x plus 1. If we had another one, it'd be x plus 2, and another one would be x plus 3. You see what I mean? Now, they only said 2 consecutive integers, so we just need the first 2, x times x plus 1. But if it was 3 consecutive integers, it'd be x times x plus 1 times x plus 2. All right, now, it says product, which means I need to multiply this out. Remember, to solve this equation, I got to have two things. I got to be factored on one side and equal to 0 on the other side. And the equal to 0 part must happen first. So I need to subtract 756. Now to do that, this must be multiplied out. So you can go ahead and multiply, or you could go ahead and subtract 756. It doesn't matter to me. I'm going to multiply. X times x is x squared. X times 1 is x equals 756. And I'm going to subtract 756 from both sides. So it gives me x squared plus x minus 756 equals 0. Now it's time to factor. So I've got my 0 on one side. Now I need to factor. So I'm trying to find numbers that multiply to be 756, but add to be 1. Okay? In fact, they have to multiply to be negative 756. Now you're thinking, oh my goodness, that's going to take forever. Well, I know they're real close to each other, the two numbers. First of all, because it's two consecutive integers, I know that. But next, the only way to add to be 1 when one's positive and one's negative, because it multiplies to be a negative, is if they're really close to each other, right? So what I'm going to do to kind of cheat is I'm going to take the square root of 756 to figure out what's kind of right there in the middle. And when I do that on my calculator, stand by just a second while I get that ready. 756, take the square root. It gives me 27.495. So I'm going to see if 28 goes into 756. So 756 divided by 28. And it does, 27 times. Alright, so I found it real quick. A positive 28 and a negative 27 multiply to be 756 and add to be 1. Now we're not done. That's not my two numbers. Remember, all that did was factor it. So now I have x plus 28 times x minus 27 equals 0. So now I set each factor equal to 0. X plus 28 equal to 0 and x minus 27 equal to 0. Now to solve this one, I subtract 28. So x is negative 28 and I circle it. I add 27, x is positive 27. Now, it says the product of two consecutive integers. Now, if one of them's x, the next one's x plus 1. Okay, now let's think about this for a minute. If x is 27, then x plus 1 would be 28. If you multiply those together, you do get 756. Okay, what about the other option? What if x is negative 28? Okay, then the next number in line would be negative 27. If you multiply those together, you also get 756. Okay, so actually I have two answers. 27 and 28 multiplied to be 756, and negative 28 times negative 27 are also consecutive integers that multiply to be 756. Now sometimes the problems will say two positive integers, so that would be this case only if it said two positive integers, but this problem didn't say that. Now let's keep going. If you'll notice, the screen moved over just a little bit because I was missing some words here, so I had to slide. But a rectangular sign has an area of 54 square feet. So we have this rectangular sign, and the area, that's all the stuff inside, is 54 square feet. The length of the sign this way is 3 feet more than the width. So if we call this the width over here, the length would be the width plus 3. Okay, so again, the important hint, the length of the sign, the length is 3 feet more than the width. It's not 3 feet, it's 3 feet more than width. Well, we don't know what the width is, so all we can do is whatever the width is, we're going to add 3 to it. And how do you find the area of a rectangle? It's length times width, right? So remember, this is the length, is W plus 3, and this is the width. We just called it W because we don't know what it is or anything about it. And we know if we multiply length times width, that equals the area of a rectangle. Okay, so our length is W plus 3. our width, we just called it W, and that equals the area of our rectangle, which is 54. So now this looks very similar to what we had in red over here. I can't solve this because I need a 0 over here, so I'm going to have to subtract 54. But before I do that, let's expand this. So I have W squared plus 3W equals 54. I'm going to subtract 54 from both sides of this equation. That gives me W squared plus 3W minus 54 equals 0. Now I have to factor. And I'm trying to find numbers that multiply to be negative 54 and add to be positive 3. We know we can do that because we have a leading coefficient of 1 right here. And if you think about factors of 54, most of you probably think about 9 and 6 first. And that would work because if we do a plus 9 and a minus 6, let's think about it. W plus 9 times W minus 6 equals 0. That definitely multiplies to be negative 54, adds to be 3. So now I have two separate answers. W plus 9 equals 0 and W minus 6 equals 0. I subtract the 9 and get W equals negative 9. Now remember what we're solving for. That's width. The width of a rectangle cannot be negative 9. So I just cross through it because it doesn't make any sense. Now I add 6, I get W equals 6. That makes sense, right? So W, we'll write this in a different color. This is our final answer. A different color. So W equals 6. We found that down here. And then what would the length be? Well, if W is 6, it'd be 6 plus 3. So the length would be 9. And what units are we talking about? Well, remember, we're talking about feet. So this is 6 feet and 9 feet are my final answer. All right, for our last problem, consider a right triangle. The length of one side, so a right triangle, you know what that means, is that one of the corners of your triangle is a 90-degree angle. So that's perpendicular, straight up and down here, horizontal here. All right, so that's our 90-degree angle. This is the length of one side is 7 feet more than the other side, and the hypotenuse is 17. And most of you know the hypotenuse is the side across from the 90-degree angle. So this side right over here is 17. Okay? And then go back, it says the length of one side is 7 feet more than the other side. Now, it doesn't matter which side you label which, so one side we don't know what it is. I'm just going to call it X, and the other side is 7 feet more than X. And more than just means add 7 to it. So make sure you understand that. It says, that, again, the hypotenuse is 17, so that goes across from the 90-degree angle. The length of one side is 7 feet more than the other side. So I say this side is the longer one, and it's 7 feet more than this one. So I have to call this one something. I just called it X, and the other one's X plus 7. Now from there, they want us to find the lengths of these two sides. Now we have a special formula. It's called the Pythagorean theorem. And if you've ever done any geometry at all, you've learned about this. And it says anytime you have a right triangle, which we have here, then a squared plus b squared is equal to c squared. Now a and b are just the sides, but the c must be the hypotenuse. So in our problem, we could say x squared, which is this side, plus b could be the other side. Now I have to put the square on the outside of that x plus 7 equals, hypotenuse is 17 in this case, so 17 squared. So this is the equation that we're trying to solve. So this is what we have to solve. Now all the skills we just learned said you have to have a 0 on one side and factor it on the other side. Let's multiply this out. So I have to FOIL here, so that's x squared. If it helps to write that out twice, you should. Okay, and then 17 squared, let's go ahead and figure that out. So 17 times 17. And that's 289. Okay, and here I've got to do all of this, right? So the x squared comes down, X times x is x squared. X times 7 is 7x. 7 times x is 7x. 7 times 7 is 49. And that equals to 289 on the other side. Now I'm working with like terms. Combine, combine. So I have 2x squared plus 14x plus 49. But y'all have got to subtract that 289, right? So maybe let's go ahead and do that before we write an extra line. So what I'm saying is minus 289 minus 289, right? And so, and I had already written that, so what if I go back and I just erase this right here? And what is 49 minus 289? So again, trusty calculator, I'm sure you can do that in your head. So 49 minus 289 gives you negative 240. So instead of plus, I have a minus 240. And that's equal to 0. So again, x squared times x plus x squared is 2x squared. 7x plus 7x is 14x. 49 minus 289, so I get my 0 is minus 240. Now these have a greatest common factor of 2. So I'm going to factor that out. That's x squared plus 7x minus 120 equals 0. This is a trinomial with leading coefficient of 1, so I'm trying to find numbers that multiply to be negative 120 and add to be 7. Let's think about things that multiply to be 120 and add to be 7. So 12 and 10 won't work. What else goes in 120? So 15 goes into 120, I do believe. So I'm just, again, playing with my calculator. So 15 and 8, aha. So 15 and 8 will work because if you multiply to be a negative 120, that means one's positive and one's negative. You add to be 7, that means the 8 can be negative and the 15 can be positive. So I'm going to come over here and keep factoring. The 2 is out here, stays, and this factors into x plus 15 times x minus 8 equals 0. And I set each one of my factors equal to 0. Now, I can't set 2 equal to 0. And I set x plus 15 equal to 0 and x minus 8 equal to 0. Again, 2 equals 0. There is no solution. For x plus 15 equal to 0, I subtract 15 from both sides to get x is negative 15. And I add 8 to both sides of x minus 8 equals 0 to get x is 8. Okay? And so x is negative 15 is the length of a side, which doesn't make any sense. So that solution is out. X equals 8 makes sense. Okay, so that means in red, let's try this. This side is 8. Now this side is x, which is 8 plus 7. So 8 plus 7 means that side is 15. And then the hypotenuse is 17. So this is an 8 by 15 by 17 right triangle. I hope this helps.